I've always wanted to work in areas that I'm really interested in, and leaving an environment that our children will want to live in is really important. Public transport is absolutely a game changer, and it will be the way of the future. I'm an engineer with Downer Rail. When I'm on the train, I feel proud that I work supporting the reliability of trains.
There's 340 million journeys made every year. We look after the Waratah fleet within Sydney to make sure that the trains are operating effectively, safely. It's an extremely busy suburban rail network, so it's a huge responsibility that we have. We're providing services to our customers to make sure that passengers can get on a train every day safely, reliably. The train's always there, they're always clean, and the customers enjoy that journey to work. We're getting 30,000 signals from each train every 10 minutes. So essentially, these are trains with brains. And so turning that data into an insight, those insights, that's really the gold dust. We built a platform with Microsoft called Train DNA. It's almost like having a blood pressure reading to tell us about the health of the train.
Train DNA is going to turn that information that we're collecting into something that we can use to improve reliability of trains.
We're using Microsoft AI to be more intelligent about how we maintain and how we detect faults. We can anticipate when our trains are going to fail in the future. We can anticipate how much maintenance we're going to do and how much downtime is needed for that maintenance.
We're trying to do that via different varieties of mediums in terms of tablet computers, phones, HoloLens, which helps overlay work instructions onto their normal environment. The potential of the Train DNA platform is immense, but it could be from any particular asset. So it could be a bus, a ferry, could even be a road service. So being a science fiction geek, that's the thing that excites me, because all those things that we thought were years away, we're now actually doing, and it's an incredible place to be. We've got some exciting young people, some smart people that are really driving this change in an industry which has been quite conservative, and I think that's the thing that really excites me and keeps me going.
Everyone. The thing I really love about stories like that one there and NT Fisheries and all the other stories we've heard today is that it's real companies solving their specific domain problems using all of this new technology. It's not in the lab anymore, it's the real world. And machine learning, back when I was at university 20-something years ago, machine learning was a thing, right? But it was solely the domain of data scientists and computer scientists who could think in multi-dimensional calculus and knew what an eigenvector was, and so not me, right? And it felt very inaccessible back then. And in fact, this didn't change very much for the first, 3/4 of my career in IT. When I started working for government, finance, did consulting in healthcare and aged care and transport and all of these other domains, machine learning and artificial intelligence were these great, amazing ideas that could solve problems. But again, they were the domain of companies that had these really deep research pockets, right? Not the companies that I was working for. And so the idea of ML and AI was very promising, but really doing it in the real world was a bit difficult, even up to as recently as a handful of years ago. 5 years ago, one of my favorite webcomics, Randall Munroe, publishes XKCD, and he had this comic about how impossible it was to do something like identify whether a photo was of a bird, right? He said you'd need a research team and 5 years to be able to solve that problem. If you fast forward 5 years from this comic to today, that's more or less a solved problem. That is now an API call. It's a handful of lines of code. And it costs you a fraction of a cent to do this. Right? So you don't need these research departments anymore. And so as we've seen today, a lot of these capabilities are starting to become available to companies just like yours. Every place, every industry, and every profession is becoming digitized. And as we heard earlier, this democratization of AI in this intelligent cloud era means that the price of entry for this stuff has never been lower. So Microsoft has reached a few milestones we saw earlier. As Satya mentioned, all of these improvements to AI capabilities over the past few years have been largely driven by the cloud, right? All of this additional power that is now available to everybody, and these limitless data stores and ways of storing your own data mean that you can do this stuff in your organization as well. We reached human parity in object recognition, speech recognition, and translation, even reading comprehension, which blows my mind a little bit. The best thing about this, though, is this isn't just our research projects. Like, it doesn't stop there. All of this technology feeds into our products that we put into Azure. So no matter where you are in your process, there's a product inside Azure that can kind of help. We have a lot of these best-in-class technologies, from out-of-the-box services that don't need any specialist knowledge, things like handwriting recognition, speech and language services, intelligent search tools, even things that are relatively new like the form recognizer, which can look at a picture of a form and give you key value pairs out of that form and automatically read what's in it. And then, of course, you can go a little bit further and use some of these pre-trained models, but you can tune them to your own domains to take advantage of all of the Microsoft research I mentioned, but target them at your specific business problems. Things like custom vision, speaker recognition and custom speech models, language understanding as well. All of these technologies are available to you as well. And then, of course, if you want to go one step further, and we've seen a few examples of that today, there's all of these services and infrastructure that are available to you to build and train your own custom models using the languages and the tools and the frameworks that you're used to. And we will enable that. One thing I want to point out, though, is that all of this, no matter how amazing it seems, it's just software. Right? So if you build an incredibly impressive predictive model and deploy it out to production, you're still deploying software out to your users. And so all of these techniques that we've come to love and come to use with deploying our software, they can still be applied to these machine learning projects, and it's really important to do so. So let's take a step back for a second, and we'll talk about this machine learning process. Now, I'm not a data scientist, I'm not a machine learning expert, but I've worked out that at a high level, machine learning projects work pretty much like this. There's a whole big set of data that you get, and then you need to do some work on that data to make it trainable, to use that data in a way that's going to give you your effective predictive models. There's some training and building of those models that goes on, and that can require a lot of data and a lot of compute. And then when you get a model at the other end, you need to evaluate that model to work out whether it's delivering what you want it to deliver. And then, of course, this is a highly experimental, iterative process, so you need to go back to the drawing board at some point, whether that's to go back to the data that you have originally or back to the training to maybe choose a better algorithm or tune your hyperparameters or something like that. Now, when you've done all of this, you still need to deploy this somehow to production. And this, when I started talking to a lot of data scientists about it, became really familiar. We get this same story where we end up with this artifact that we somehow need to throw over the wall to the developers and operations teams to put in production somehow. Right? If we compare this to the way that DevOps works and the way that we've started developing software over the last few decades, where we have this planning phase, where we know what we're going to work on in short increments. We do our development and our testing to make sure that what we're developing is the right stuff. And then we release that software to pre-production environments, then to production environments, and make sure that all works. And then we close that loop. And we monitor what's happening in production, and we learn from that as well. Not just catching exceptions and reading logs, but identifying whether we're delivering value to the customer, whether what we thought this was going to deliver is actually being delivered. But can this apply to machine learning projects? And the short answer is yes. This is Microsoft's definition of DevOps, that DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Now, the most important word there, and I've highlighted it, is value. DevOps is not about delivering features to production. It's not about delivering bug fixes or scalable infrastructure. It's about delivering value. It's really easy to deploy a new feature into production, but if nobody uses it and it doesn't provide any value, then you're kind of wasting your time. If we think about this from an ML project perspective, think about a predictive model that you have to do something like identify fish or identify when you're going to do preventative maintenance on your train system. Right? If you think about those examples, if you can improve that predictive model to give you a better outcome, then you're absolutely delivering value. So we don't need to change our definition of DevOps or come up with a new definition. We just need to start using some of these techniques that we've become used to in our machine learning projects. So I want to show you a bit of an example calling back to what Sonia introduced before, which is Tailwind Traders. Right? I'm going to use 2 Azure products to help me with this, and we're going to build an end-to-end pipeline which will allow me to update my training algorithms and end up with a production-ready model that improves value for our customers. I'm going to use 2 products. We're going to use Azure DevOps, and specifically Azure Pipelines, to do our building of this pipeline and then our deployment into production. And I'm also going to use Azure Machine Learning, which is a set of services that can do everything for your machine learning projects. It's incredibly powerful. Everything from hosted authoring tools, things like hosted Jupyter notebooks and even RStudio as of recently. AutoML, which really shortens that time to market initially by doing things like automatically working out which algorithms are going to work best for the data that you have. And then even the visual interface. So even if you don't want to write any of this code, you can start dragging and dropping different algorithms around, different data sources around, and connecting those dots so you get a visual picture of what your training pipeline looks like. So there's the authoring tools. There's also the assets that you need to manage as part of your machine learning process. So things like data sets and the experiments that you've actually run and want to track, those training runs. The training pipelines themselves, versioned according to what updates you've made in that pipeline. And as well as that, when you've come up with models, these predictive models, you need to version those. So it will track the models that you've produced, some metrics around those models, any of the graphing and all of that great detail that you've collected as you were training that model, and version those so that you can deploy them as you need. And even containerized deployments. So you can take those models, wrap them in containers, and deploy them to Azure Container Instances or Azure Kubernetes Service directly from Azure Machine Learning. And then, of course, there's all the stuff you need to do the training itself. Things like the managed scalable compute. My laptop doesn't do very well with deep learning, right? It's not terribly powerful. But Azure has some pretty powerful machines that you've no doubt seen in the portal that can do that work. Very heavy GPU intensive machines and things with FPGAs. Obviously, I'm not a data scientist. That can do this work for you in a much better and scalable way so that you're not paying for a few hundred kilos of metal in a freezing cold room somewhere in your business. Right? You only pay for it when you use it. And of course, you need to do things like define your environments. The environment you use to train, so you have that consistency, but also the environments that you need to do your inferencing, to actually run your production workloads. And also your connections to all of your data stores, where all of that data lives. So let's just jump ahead, and we're going to look at an example of a training pipeline for Tailwind Traders. So this is their website, and they have a really interesting feature where you can search for a product not by typing in a search field, but by uploading a photo of that product. Now, whoever came up with this idea, I'm not sure they thought about it much, because if you have a photo of a wrench, you probably don't need one because you've clearly got a wrench. But it works quite well with some of these pictures, but it doesn't work so well with others. So here's my claw hammer, and if I upload that picture, it still thinks it's a wrench. Right? So this is one example. We want to fix this. We want to come up with a better predictive model. Now, just like the rest of my software, I can open an IDE. My data scientist can work out what needs to change. In this case, they just needed to tune some hyperparameters. I'm using Visual Studio Online, by the way, so this is not even an installed application. I will make those changes. I will commit and push those changes to my Git repository. Just like all of my traditional software, that will kick off a deployment pipeline or a build pipeline. So we'll do a continuous integration build using Azure pipelines. Why Azure pipelines? Well, ultimately, we're dealing with code here. And a CI system a continuous integration system, is really good at doing things like verifying how good your code is and that it meets your standards and that your changes integrated with everybody else's changes work really well. So you can see we're doing static code analysis. We're even running tests because it's Python. You can run tests. And then at the end, we're recreating and submitting an Azure machine learning pipeline because we have changed the way that we're going to train our model. So what does that pipeline look like? Well, that's an integration to Azure Machine Learning. So if we jump over to Azure Machine Learning, we can see a few of the training runs that we've already run in previous versions. And while we're waiting for that to kick off a new run, let's look at what that involves. And I have a really basic pipeline here. I have a data preparation step, which grabs my images and does some things with them. It does a model training step, which can take a little bit of time, and then a model registration step, where we're registering that version of the model that we've produced. Now, along the way, I'm using Azure Compute. And here, this is a very basic pipeline. I'm just using one machine doing one task, and it's not parallel. But I have a cluster here that I've defined that can scale up from 1 to 4 nodes, depending on how much I want to use. So if I had a parallelizable training pipeline, I can dramatically reduce the time until I get that model out ready for production. So let's go back and have a look at this training run that we've got here. This is run 49 that's running right now. And I have the advantage that I have this magic clicker that can kind of fast forward through this process. We don't want to watch that progress bar training. So we've finished our model training, we're registering that model, and now we have this versioned model inside Azure Machine Learning that we can deploy when we want to. Now, I could add another task to this pipeline that would automatically just deploy it to an Azure container instance, but I don't want to do that. I want to hand control back to Azure pipelines in a release definition. And the reason I want to do that is control. So right here, we have an agent that's picked up this release. It's picked up that model. And if we have a look, we can see it's automatically deployed, or it's automatically starting this deployment based on this new model being registered in Azure Machine Learning. Again, the integration between these two tools. So when there is a new model ready, we will kick off a release pipeline, and we will deploy to Azure Container Instance. So let's fast forward again. And we're getting close to deploying that. We've got this deployment to Azure Container Instance, and we're ready to go. But let's have a look at what else we can do in this pipeline. And this is where some of the control comes in. We can see that we have our continuous deployment trigger. And right now, we're deploying to what we're using as production. But in the real world, you probably don't want to go directly to production. You want to deploy to a test site, and then maybe deploy to production. But you also want a bit of control over when you're going to deploy to production. So, and what you're going to do in that deployment too. So before we were deploying to Azure Container Instances, my production environment might need a little bit of scale, so I can deploy to Azure Kubernetes Service as well and scale that up. Or maybe I want to download the model and embed it in my mobile application. One thing I really want to do is control that deployment to production. So I could add a pre-deployment approval and decide that I am the one who has to click that approval button before it will go to production. Or I could skip the manual stuff completely and use gates. And these deployment gates allow me to do things like even kick off a new Azure ML published pipeline. And to call back to what Sonia was talking about before, I can even check my Azure policy compliance before I deploy that new model to production, which is really handy. So all of the other things that I might want to do here, things like feature flags, A/B testing, gradual rollouts, all of that kind of stuff I can control. But ultimately, I'm delivering value. So if we look at this model that's just been deployed and we upload our hammer, we can see, great, it's given us a better result. The big benefit of this, though, is that I have delivered value to my customers, and all I had to do as a team was make a change to that training code, and my pipeline picked everything up, safely rolled it out through my pipeline, ultimately to production. I can put whatever controls I want in the way and whatever rollout mechanisms I want to control that deployment. The most important thing here, though, is that my data scientists and my machine learning experts are doing data science and machine learning. They're not copying files to a production system or putting out the fires when that copy doesn't work very well. Right? They're concentrating on their core capabilities. We're letting our smart people do the smart things. So what do we build here? We built a basic pipeline, right? We did some model preparation, some training, some model registration. That was a really easy one, but you can make these as complex as you want, clearly. We did this inside Azure Machine Learning, and then once we had a model at the other end, we used Azure DevOps and a release pipeline to control that deployment to Azure Container Instance. We would maybe measure how that's performing, and then once we're ready, deploy it to production, maybe to Azure Kubernetes Service. So this pipeline is what we ended up with. When we changed this pipeline, we changed the way that we trained our model. We refreshed this pipeline and kicked off another training job, and ultimately ended up with another model in production. But the story shouldn't stop here. Just like when you deploy a piece of software to production, you don't expect that that's always going to be valuable to everybody. You want to monitor what's happening in production and update that software when it needs updating, and you want to do that in a safe way. So you really need a retraining strategy. Now, this might be a really simple case of periodically just doing a new training run to incorporate the new sales data that you've got. Or maybe every week you get a new shipment of products, and so you just want to retrain using those new products for your recommendation engine. But wouldn't it be good if you could preempt that and look at when you're likely to need to change your model based on what's actually happening in production? And one of the really cool features of Azure Machine Learning is this idea of data drift. And so how it works, essentially, is that we want to monitor what's happening in production and what's happening based on what real data we're getting through and comparing that to what data we trained our model on, and automatically kick off this pipeline when it's ready to go. We do this by training against a known training data set. So this feeds into our model. We end up with this model in production that's ready to use, and then in production, when we're using it with real users, we collect that data and we put that into another data set, an inferencing data set that can identify what we're actually seeing in the real world. Azure Machine Learning will periodically compare those two data sets and identify when that data has drifted by a certain amount. And you can even set that up to automatically kick off a new training run. And if you want, when you get that model out the other end, compare that model against the old model with the new data to make sure you are actually delivering value. And all of this, once set up, can be hands-off. So this is incredibly powerful and really lets our experts focus on the stuff they're experts at. We're closing that loop and making sure that we're delivering value. So no matter what stage you're at in your AI journey as a company, there's a service in Azure that can help you, but mainly it's for these building blocks for your own AI-first digital capabilities. We're not giving you silver bullets here. We're giving you the ways that you can solve your own company's problems. And there's much more coming in this space, particularly around shortening that lead time, the first time that you can put something that uses AI in production, but as well as that, all of the DevOps stuff around how you actually get this software, this machine learning, into production in a nice, safe, repeatable way. And as you're building these capabilities, remember that this is all just software that you're deploying into production. The idea is to deliver value to your end users. So I'm saying here that DevOps is the union of people, process, products to deliver continuous value, but you could equally say MLOps, machine learning ops, DevOps for machine learning, whatever you want to call it. It is also about delivering value to production. So I want to really highlight that now is the time to start investing in this stuff. But remember, this is software that you're delivering to your customers, and you need to treat it like software that you're delivering to your customers in a safe way and in a smooth way to make sure that everybody is actually getting value from what you're producing. Thank you so much. Have a good afternoon.